Hello, this is the Bite Weasel, and in this video we'll be continuing our Obby tutorial, this time looking at how to save the state of the player so that they restart at their latest checkpoint. So at this point we have quite a few different areas that the player has to traverse, from the start point all the way up to that last one that we made with the laser beams. And you can see we have about 9, although it looks like we made a mistake. And at some point, we have a blank area in here called Area 5. So let's take a look at what Area 5 was supposed to be. Area 6 is the doors. Area 4 is the stairs here. So it looks like we're missing Area 5. That must have been a mistake in the previous videos. I tell you what, let's just make a brand new area using some of the things that we already have. So we can move all of these things along a bit. And then inside area 5, let's make something akin to these stairs. I think that should be good. So we can copy these and we can paste them into area 5 like so, and just move them across. Looks like they're a little too high for whatever reason, but there we go. Have them like that, and then each one of these we can sort of move up, make another jumping platform. And I think that's okay. But what I'd like to do is sort of make them a little more tricky than just the original jumping platform over there. So what we can do is combine the vanishing script that each one of these stairs currently has with the moving script that we added in last episode. So how we can do that is we can sort of convert one of these stairs into a moving vanishing stair. So how can we do that? Well, we'd right click and choose group as model, and then we'd call it moving stair, or whatever you want to call it, and we'd add into this our mover tag from last episode. Now, if you recall, when you have a mover tag, you need to do some special things for that model. You need to call your moving piece move, and you need to make sure that it is unanchored. We turn off that. The other thing is that you need a submodel called targets that has inside it several different points that the platform can move to. And we number these 1 to however many points you want. So I've copied one of those things in there, but our points do need to be anchored. They do need to have no collision, and they do need to be a bit smaller. I guess we can also make them hidden because we don't really want people to see them. So there we go. Now we can have them move over here, duplicate it, move over here, name this one number 2. And now we've got a moving vanishing stair. So what I'd like to do is replace this one, like the second one along, with one of these. So we'll duplicate that, we'll move it down, and now we've got 2 moving stairs. So let's use our little tip here for play here, and take a look at our new Area 5. Now isn't that cool? With very little changes, oh gosh, they disappear and move at the same time. So that's a cool thing about our scripts. The way that we're using collection service and tags means that you can actually combine these with any of our other existing tags. So here I've combined the moving tag on this outer model with the vanishing tag on this inner one. I think what I'd just like to do though is make these 2 move the other way around. So we'll have this one number 1 and this one number 2. So now if I look, they should go the opposite direction. Yeah, which I think is pretty cool. But they still vanish when you stand on them, so you have to be pretty quick. So that's pretty neat. Oh dear, I fell off. Now, because of the way I sort of duplicated these things, you may have noticed it if you're watching carefully. These points actually have the vanish tag still on them. So let's get rid of that. And we can also turn off touch and query on these things since it doesn't really matter. So that should work nicely now. But we're still at the point where if you fall off, you start from the beginning every time. So I think now is the time to fix that by adding a new checkpoint system into our game. So the way that we created these areas originally is that each area has this safe stage part on it called stage. So I think the easiest thing we can do is first tag these things as our checkpoints, and then add a script that when they get touched, we store the state of the player as this is the last checkpoint, right? We really should have added a tag before we started duplicating these things, but that's okay. We can just go through and select every single area, every single stage part within each area, and then tag them. So if I go down here and here and here, I think that's them all selected. Yeah, looks good. So now we go down to tags, add a new tag, and I guess I'll call it checkpoint. So these things are checkpoints. And now we're going to use a very similar script to our original damage script, where they look through a tag and add a touch event to them. But instead of damaging when they get touched, we're going to save your last checkpoint when you get touched. Pretty straightforward then. We go down to server script service, we add a new script, we call it checkpoints, and we can just copy our existing damage script. So go to checkpoints, paste that in there, and then just update this to checkpoint. So if you recall, our script will work using the collection service. It will look for that tag called checkpoint, and then when anything is added in the world, it calls added. When anything with that tag is removed, it calls on remove. So we already have a touch event attached to the item. Currently, though, it damages the player. So we're going to replace all of that with code to just sort of save the state of the player. So this is actually pretty straightforward. What we can do is at the top here, have another sort of state table that instead of storing state for each individual tagged item, we're going to be storing state for the player, like data for each player. So what we can do here, where we originally had the damage code, instead we're going to want to update the state of this data table for each player. So the first thing we need to do is figure out what player touched us. We currently know the character and we know they're a humanoid, but we don't know which player exactly. So to get that, you can basically go local players equals game get service players service. Now this built-in players service has a handy function on it called get player from character. And you can pass in the character which we already know up here. And this will return to you the player. Now, in case something goes wrong and this character, even though it's a humanoid, is somehow not a player or the player has left the game, we can do a guard check that says if not player, then return early. Okay? Now at this point, we do have something. So we can say data player dot checkpoint equals, and then the name of the checkpoint that we want to use. So checkpoint, which is item.name. So that's pretty good, but it's got a couple of issues. The first is that this checkpoint that we're trying to store, we're using the name. Now that is not going to work because all of these items that we've tagged with checkpoint have the same name. They have the name stage. So we need some way of identifying each one uniquely. And there are, of course, several ways of doing this. We could, for each one of our stages, add a brand new attribute that has a unique name. So this could be stage 8, this could be stage 7, and so on. The problem with doing that is when you duplicate it, you'd have to remember to come back up and rename it. And we're already doing a rename whenever we duplicate one of these areas. So it might be nice to just use this existing name that we have that is already unique and already has a number built in. So instead of getting the checkpoint from the stage.name, which would just be stage, we can get it from the item.parent.name. And that's going to give us area 8, area 7, area 6, and so on. So that's a good unique name to remember which checkpoint the player is at. Now the other problem with this is right now there is no player data, right? There is nothing in here. So this will be nil, and you can't say nil.checkpoint. This will throw an error. So we need to fix this by setting some default value for the data for each player. Well, we can do that by using another function on the players service, which is actually an event called player added. And this event will fire whenever a player joins the game. So we can connect up to it with a new function, just like we do all our other events. So a player has just joined the game. We can basically say data for this player equals a brand new table with the word checkpoint equal to nothing, because they have no checkpoints. So now when they touch a new checkpoint, this will be a valid default table, and we can update the checkpoint to have this particular name. So that's cool. The problem is, what do we do with this checkpoint? Now we've stored this checkpoint whenever they touch a new stage. How do we actually move the player to this checkpoint when they fall off the world and respawn? Well, when you respawn or when you first join a game, there is actually another event that gets fired. And it's called character adding. And you get that from the player object itself. And it's right here, player.characterAdded. And this is an event that we can connect up to just like before. But this one is going to give us the character model that was just loaded for the player. And so this happens when the player joins the game for the first time or when the player respawns in the existing game. So now what we can do is just look up to see what their last checkpoint was. We can do that by saying data for this player dot checkpoint. And this will be the name of that area that they last touched, right? So what we need to do is find the stage for that area and teleport the player to it. So we can do that by first checking to see if this is not nil, right? If not name, then return early, right? If there is no checkpoint, because this is the first time they spawned, then we'll just return early. Otherwise, we'll get the stage by saying stage equals game.workspace find first child of that checkpoint name, right? Because that's going to be this folder that we stored under there. And then assuming that we get that, so let's just guard check it. If not stage, then return early. For some reason it got corrupt. Otherwise, we can say local. Actually, these aren't stages. They're really the folder. So they're called areas, right? And then the actual stage itself, local stage, is area.stage, right? That will be the part under that named area folder. So there we go. Now we can teleport the player by using character, which has a function on it called pivot to, and then you can give it the target C frame that you want to go to, which will be the stage. And then we can just get the pivot point, which is the middle of that stage. Now that would be good, but it would put the middle of the character to the middle of the stage, which means their body would be stuck in between it. So we just have to move them up a little bit with a new vector 3 of about 3 studs high, right? So this is going to move them to the middle of the stage up a bit. So that should work. Let's double check what's happened. So when they touch an item that has been tagged with checkpoint, we're basically going to update the data table for that particular player to be equal to the stage.parent's name. So area 7 folder, for example. Then when the player actually respawns, we're going to check for that data. If there's no name, we return early. Then we look for the folder with that name in the workspace. If that's not there, we return early. Otherwise, we grab the stage under that folder and we teleport the player there. So let's check it out by using play to start from the beginning. So we're starting from the beginning. Now let's check by hitting this checkpoint right here and then jumping off. Whee! We should, in theory, spawn right back at that checkpoint. And we do. Yay, that was easy. So now we have an easier way of actually playing this obby. So if I go up here, let's see how far I can get. The stairs. Oh. The vanishing stairs. That was a close one. Now this I do remember is these two and then this one. And this I remember is diagonal. Oh my gosh. I'm doing so well. This we just have to wait. Yeah. Are we going to make it all the way? Maybe. We just have to jump underneath and underneath. We did it! So now if I was to fall off, I should be right at the end. To be honest, I was expecting I was expecting not to make it to the end. But there we go. How cool is that? Really easy way of storing the state for that particular player. Woo! Now you can go backwards as well. But currently what happens is, because this was the last checkpoint I stood on, if I respawn now, it will be this checkpoint. And maybe that's okay, but maybe you don't want to allow people to go backwards in the game and save that, right? Maybe if they go backwards, you want to say, oh, well, that checkpoint they just touched is further back than the previous one, so I do not want them to save as the latest. And to do that, we need some sort of check that says, hey, the new checkpoint that you just touched, is it further on in the game than the previous one, or have they gone backwards? And if they've gone backwards, I do not want to update their latest checkpoint. So we can do that because of the way that we've named our folders, and each one is incremented from the last one. So this was a good way of us creating our hierarchy, because we have these in order areas, and we know that, hey, if you went to the last one and then you go to like area 6, well, that's lower than area 9, so do not update it. What we really need is that number on the end there. And there are some ways of doing that. So let me just show you how we can do that. So first we can get the name of that area by saying name equals that. Then we can get a number from this by just taking that whole name and replacing the word area with nothing. And that will leave us with just the number we want. So to do that in Lua, you can sort of say name and then this G sub, which allows you to globally substitute a pattern with a replacement. So we're going to replace the word area with nothing. And that will return to us a name that is just a number. And then to convert that to a number from a string, we can say toNumber. Now you have to be careful with gsub because it looks like it would only return a single string, but in fact, it's cut off there at the end of that documentation tooltip. It actually returns a string and a number combined together. The string being the new value that you just substituted, and the number is how many times it found a substitution to make. So that gets a bit wonky when you pass it into toNumber because this only expects a single string value. So what you can do is wrap this in an extra set of brackets so that it only takes the first parameter, which is going to be the string. I know that's a bit complicated, but to convert a gsubbed thing into a number, you have to add these extra brackets in there. So that will give us the actual ID of the new area that they just touched. Now to compare it with the one that they previously have, we have to look at this. But this could be nil, because if they just joined the game, we set it to nil. So we need to do that check too. So we can say, if the checkpoint is not nil, then we'll do an additional check. Otherwise, we will update this thing. So if this is nil, it's going to skip this additional check and update it. Because if they've touched something and we don't have one saved, that's fine. But if we do have one saved, we need to double check that the new one, which is this new ID, is later than this existing ID. So we can say old ID equals, and then a very similar toNumber, all of that gsub area. We need to replace this, turning the area into nothing, which will give us back a number, which we can convert here. And then we'll just say if, I think I missed a bracket there. We can say if new is less than the old, then return early. If they stand on a new one, but it is before the one that they previously stood on, then return early. So if they stand on 5 and it's less than the one that they last touched, which was 9, then return early. So this should work, and it should allow us to no longer go back backwards. So let me show you. If I go to this one and I respawn, I should be just before the turrets. And I am. But now if I go back here backwards and I touch this one and then respawn, I should still be at the turrets. Because I tried to go backwards and our new check there prevented it from updating the state. Nice. Cool. So that was pretty easy. Now, one thing that you probably have noticed is that whenever you restart, oh dear, we're back at the beginning. And nobody likes that for their obbies. If you go away and you have some lunch, and then you come back and you have to start again, that's really annoying. So let's fix that next. But the first thing I want to do is get rid of this cheating platform. We don't really need it anymore, because if I reach this ever, I'm going to respawn there. So that's nice. So the way to make data saved between people quitting the game and rejoining is with a thing called the DataStoreService. Now, the DataStoreService is kind of complicated, and the best way to really use it is with a library. So there are many, many libraries out there. The one that I like to use is called Profile Service. And that's really what you should look into when you come to do a very complicated game with lots of data that you're going to update a whole bunch, and it's going to store lots of different things with lots of different players. But for a simple obby like this, and for my tutorial here, I'm just going to show you how to do the basics using the pure Roblox APIs. Now, I do recommend that you look into some data store libraries if you come to do a complicated game, but just for an easy obby like this with only a couple of things saved, it's probably going to be fine to just use the built-in APIs. So to do that with the built-in APIs, you need access to the data store service, which is just the same way you get all the other services, data store service. And the way that the data store service works is you need to call a function on it to get access to an actual data store. So you can call get data store, and then you have to give it a unique name for this particular data store. So in Roblox, each data store is unique per game. So you can use the same name in all of your games. The problem is it's not unique in the same game between testing mode in Studio and a live published game, which means if you use that same name in both Studio and live, you can end up accidentally overwriting your data when you're messing around trying to develop your new update. So the best way to combat that is to actually choose a different name for when you're in Studio versus when you've actually published the game. So we can do that with a new service called the run service. So we can get that as well. Get service, run service. Now the run service is handy because it has a function on it called isStudio, and that will return true if the script is running in Studio and false if the script is running on a real live published game. So we can say local data store name equals, and then we'll check with the run service to see if this is Studio or not. So if the script is running in Studio, what I want it to return is the word test, or if it's not, I want it to return the word live. And then I'm going to take that word and I'm going to combine it with the string / player data. Now this is a weird way of sort of in Lua doing an inline if check. And basically it looks at this first one and it says, if it's true, then true combined with this. So it will check this and return this part. But if this is false, it will say false and something is false. So I'm going to return whatever's after the or. So it's kind of a weird way of doing an inline if check, where if this is true, it returns the first thing, or if it's false, it returns the second thing. So this is going to say test if Studio is true, and live if Studio is false, and we're actually running the script in a live game. So we can take that data store and actually pass it in here. So now our data is protected for when we publish the game, it will only modify live player data, and when we're editing the game, it will modify test player data. So we never break anything on a live server, even if we mess around with it in Studio. So that's handy. And then the way to actually access this stuff is to grab the result of this get data store as your data store, right? So local data store equals get data store of that name. And now this data store has two functions on it that are useful. One is called get and the other is called set. So what we're going to do here is actually call data store get async, right? And this will return the data in that data store for a particular key. So it needs a key that has to be unique for each player. And that key has to be a string. So we have something on a player called user ID that is unique for every single player. So even if the player has the same display name or account name as someone else, their user ID will still be unique. So this is a great key to use. Unfortunately, user ID is a number, not a string. So you need to actually make it into a string by combining it with something. And I always like to combine it with the word player underscore. You don't have to, as long as you turn it into a string somehow and it's unique. So there we go. Get async for player underscore this particular ID. So that will return to us some data that it loads if it exists. Now the problem is sometimes data stores fail, and that is another reason why looking at a library is kind of useful, because it handles all these weird edge cases for you. But for just our pure thing, the easiest way is to protect yourself using a built-in Roblox function called pcall. And you can pass into pcall a function, and what will happen is it will run this function in a protected way. That's what the P stands for. So this protected way means that if this fails, instead of it throwing an error and your script sort of bailing out, this function will return to you whether or not it succeeded or not. So you can say success equals pcall of this. And then if you want to get data out of this, you can return it, and that will be the second parameter that pcall has as a result. So we can say loaded data is what actually gets returned, and success is whether pcall failed or passed. So then we can do a guard check. If not success, because pcall failed because the data store wasn't available for some reason, or not loaded data, then the data is going to be our default value. Otherwise, so with an else, data for this player is going to be whatever we loaded out of that data store. So the loaded data. Now, when a player first joins the game, we're going to do a protected call to get async of this particular player's data. And if it succeeds, and there's some loaded data, we'll come here. But if it doesn't succeed, or there's no loaded data because they've never played before, then we will have this default value just like we did before. So that's great, but now we need to update that when they leave the game, right? When they leave the game, we want to actually store this back again. So how do we know when a player leaves the game? Well, players has another thing on it called player removing, and you can connect up to that just like we did all of our other functions. But now we can store the data back. So it's very similar to the get, except it's a set. The key is still the same, but the value is going to be whatever the data is that you want to store. In our case, the data for that particular player. And there we go. We don't really need to return anything because we don't care about set, but we might want to care if the pcall succeeded or not. So we can say if not succeeded, then we can just warn ourselves, and we can say player data was not saved, something like that. There's no real action that we can take here if this fails, but at least we'll see an error in the console or an error in Roblox's metadata when you look and publish the game. So that, with that little change of adding a data store get and a data store set, we now should have a way to load and save data even when they quit the game. The problem is you can't actually use these APIs from Roblox Studio unless you've saved the game to Roblox. So we have to come up here and we have to choose Save to Roblox. Now, if you've never done this before, there'll be a bunch of information you have to fill in, a name, the devices, who the creator is, and stuff like that. But I already have one, so I'm just going to save as, this particular obby that I've already used and overwrite it. So there we go. Once you've done that, you can then click on your game here, go over to game settings, go down to security, and you have to make sure that enable studio access to API services is turned on. If this is off, then you'll get a warning in the console when you try and use the data store. If you haven't saved it to Roblox, you have no way of accessing this setting, so you'll get the same warning. So make sure you've saved it to Roblox and this is turned on. Now, once you've done that, you can actually play the game, and we should see that we start at the beginning because I have no saved data. Oh, okay, ignore that. What you should see is when I successfully pass this first obstacle, yay, inside the game, if I fall off, I should respawn here. But now if I stop and start the game, I'm still here, yay, because we stored it in the data store when we got here, and then we reloaded it when I joined the game. So that is a really easy way of just storing state for your game. But you're probably asking yourself, okay, well, what happens if I get all the way to the end and then I want to retest back from the beginning? That's not going to work, is it? Because the data is going to be saved. Oh, I missed. But if I wanted to start back at the beginning, what would I do? The problem is, whenever I join, I'm going to be here now. Well, there are two ways to fix this. One is in your code, we can just sort of edit this if statement so that if it does find loaded data, it resets it back to 0 anyway, right? Getting rid of that not means that it loaded data, but we reset it back to default anyway. So that's one way of doing it. Another way of doing it is with a plugin. So there's a plugin that you can get called Data Delve, and this one is really cool. It allows you to inspect any data stores in your game. So we can type in here the name of our data store, which is, if you recall, test/player data. We can connect to that, and then we do see a list of all the data stored in that store. Right now there's only one. It is our data object, but you can delete that, confirm, then you don't have one anymore. So when you play the game, you're going to start back from the beginning. So let me just prove that by going here, falling off the world. We respawn here in game. And see, if I stop and start the game, we respawn at that same point. But if I stop the game and I use my plugin to go to my player data, you can see there's the saved data, area 1. I can delete it. Yes. Yes. Close this, play again, and we're back from the beginning. So use a plugin to edit the data store or just make your script load default data anyway, and you are off to the races. We now have a way of, oh dear, remembering the last checkpoint that you got to, even when you quit the game and rejoin. So now your obby becomes much more fun to play because if you fail, you can try again without having to go back to the beginning. Oh, nuts. There you go. So now that our script is able to save and load the current stage, it might be nice to display what stage each player is at using the leaderboard. So the leaderboard is normally shown in the top right corner over here. And you've probably seen it in any games that you've joined where it has every player's name and then it has some sort of value depending on that game. And the way that that works is with a thing called leaderstats. So if we go back into our checkpoint script, we can actually update a thing called a leaderstats every time we change the checkpoint value. So let me show you what that looks like. The first thing that you need to do is when a player joins the game, create a leader stats folder. Now this is a special sort of folder that lives under the players service. And what happens is Roblox will look under the players service, it will look under each player, and if any of those players have a leader stats folder, it will put them on the scoreboard. So to make that, it's really, really simple. You basically use the instance.new function that we've seen before, and you give it a folder because that is what we want to actually create. And you have to put it, so the parent, this second parameter, under the player, right? And then you get that back by saying local leaderstats equals that new folder that we've placed under the player. But then you have to give it a special name. So you have to say leaderstats.name equals then leaderstats, all lowercase letters. It has to be this special name because this is what Roblox looks for under your player, under the player service, to actually fill in the scoreboard. And now, the way that the scoreboard works is it looks under this folder called leaderstats for any sort of Roblox value. So there are a bunch of different values you can add, like a number value or a string value, things like that. What we're going to use is a number value. So to do that, it's very, very similar. We can say local stage equals instance.new, and this is going to be a number value. And then you have to give it the parent, and the parent is going to be that leader stats folder. So this stage number value will live under the leader stats folder, and the leader stats folder will live under the player. Then you have to give your new number value a name, and this is the name that will actually appear in the scoreboard. So we'll call it stage, but you could call it like area, stage reach, score, whatever you want to call it. That is what's going to appear in the scoreboard there. And then you can give it a value. And the value is going to be whatever value you want to give it on the other part of the scoreboard. So for here, we can say data for this particular player dot checkpoint, right? But we have to do some checks here because this is actually a string. It's the name of the checkpoint, not a number. And sometimes, as you can see here, it is nil. So what we can do instead is grab the number from this checkpoint using a new local function. So we can say local function get number for stage, and it will get passed in the name of a stage, right, as a string. And what we're going to want to return out is this same gsub stuff that we did before, but we also need this check to make sure that it's not nil. So we'll copy a bit of this and paste it here. So if the name, then we can do this check here, which is return to number of the gsub of that name by replacing area with nothing and then converting that into a number. Else, because there is no name, we'll return a 0. So we can actually use this helper function now anywhere we've done this. So we can say get number for stage name. That's the name that they just touched. Otherwise, we can say get number for stage and pass in just the checkpoint part. So that's cool because we can now also use it right down here, get number for stage and get that checkpoint. And it also means that when we actually update that checkpoint over here, we can update the leader stats again. By getting the stage this time, we don't need to set the name, we just need to set the value. But how to get it? Well, we say player because that's where it is, leader stats because that's the name of the folder, dot, then the name stage because that is what we called it right here. So this should both update it when you touch a new one and set it when you first join the game. So let's take a look if it works. We can play and you can see the leaderboard has now appeared. And what's happened if I look in the player service is that under my player, here is the folder we created and here is the stage number value that we made. And it's 4 because we loaded 4 from our data store because 1, 2, 3, 4, this is the stage that we reached. And now you should see if I can make it past these things, we see that it reaches 5 when I touch here. And now if I get to the next one, it should say 6 because every time we're saving it, we're also updating the leader stats there. So that's really cool. Now you have a nice leader stats thing. And if more people join, you'll have more of these. But how do you know that's true? Well, in Roblox, there is this really handy way of testing multiple players even though you only have one computer and you're just doing it on your own. You can go over to this test tab and you can actually emulate a number of different players joining. So for example, let's emulate 2 new players joining. And you can click this start button instead of the normal play button. And what this does is it actually spins up 3 versions of Roblox Studio. This first one is the server. And then it will spin up 2 more that simulate player 1 and player 2. So it's kind of hard to see right next to each other on here, but we now have 2 people and you can control both one at a time. So here you can see on this window, I am player 2 because on this window, player 1 can see that that's player 2. Did you get it? Okay, so now what I need to do is I need to get over to there and we should see that the leaderboard updates for this particular player. Right? Unfortunately, my jump button isn't working. So that's going to make it incredibly difficult. Why isn't jump working? Come on, jump. Let me zoom into this. Maybe that will help. So there we go. Now my jump button works. So I am currently, I think, player 2. So if I get over here, you'll see that player 2 has both got a number 1 now in the stage, but has also moved to be the top of the leaderboard. Because we're using a number value, Roblox is able to order that value in the table and put those higher numbers first. So that's really nice. We can see that it works for 2 players. And if I was to quit and rejoin by stopping the server and then starting up another 2 players again, and now it's going to start the server again with player 1 and player 2. So I'm not sure which window is which, but we should see that player 2 has started over there. So it is working for multiple players. So that's a really nice way of testing your game, that it works with multiple players, even if you only have the one computer to test it on. Very nice. So that's it for this video. Thanks so much for watching. If you enjoyed it, like and subscribe, leave a comment, ring that notification bell, all that good stuff, and I will see you next time.